When we think of radio frequency applications, we typically imagine signals propagating through free space. Radar waves, FM radio signals, cell phone data, and satellite broadcasts. But RF signals must also be transmitted inside electronic systems. For example, the latest automated vehicles have vision, LiDAR, radar, telecommunication, and global positioning systems that each must transmit and receive RF signals through connected systems. As we will learn today on Tech Chat, the RF cables and connectors must be up to the task of enabling these high-performance applications in rugged and harsh environments. Today on Tech Chat, sponsored by Mouser Electronics, we are pleased to welcome engineer Ron Orban, who is currently the Senior Product Marketing Manager at Amphenol RF. He is here to talk with us about RF Interconnect for autonomous technology. Welcome to Tech Chat, Ron.
Hi, Dale. Nice to be here. Thank you.
Oh, good to have you. Since Amphenol RF is a world leader in RF connectors and specifically the world's largest manufacturer of coax connectors for RF applications, I'm really looking forward to our discussion.
Yeah, me too. Glad to be able to talk about this subject.
So, Ron, why don't you start us off by giving a quick overview of your agenda for today's discussion?
What I'd like to talk about today is what we're going to be considering autonomous technology to be, and then what some of the technology that is driving the applications in that market. We're also going to talk about some other related RF products that we offer in that space and some of the places that they're used. And then I just want to wrap up and talk about, just some of the custom capabilities that Amphenol RF offers above and beyond our standard set of products.
Well, that sounds great, Ron. Why don't we jump right into that first topic and get a definition of autonomous technology?
Autonomous technology, as we see it in our industry, is really any system that can react without human intervention to real-time events in the world. You see this probably most in the automotive industry, where there's a lot of talk about autonomous vehicles and self-driving vehicles. The autonomous standards in each industry are different, but some are more defined than others. And so in the automotive industry, you'll see that they have levels 0 through 5 for how autonomous is the system and what level of autonomy means for both the machine and the human interaction to it. Because there's different manufacturers at different levels of autonomy, we're working to support the applications that they're trying to develop to make that autonomous technology happen.
Well, you bring up a good point there, Ron, in that the general public and kind of popular culture thinks of autonomy really around automotive right now. But inside our engineering world, autonomous technology covers a lot more industries and applications.
It does. And we do see that the technology driving autonomous applications derives from industries like the automotive industry, where they've been using a set of standard products for so long. And because that particular industry is driving the autonomous applications, adapting those products, those connectors and those other applications, they're adapting them to be used in autonomous applications. And then because the transportation aspect of it is so important, the technology is cascading into other markets like industrial Internet of Things and even heavy equipment. So we're seeing those automotive applications and products being used in other markets in some similar and some vastly different ways. So it's really an interesting time to be developing applications or working with companies that are developing the applications. So in working on these applications with customers and for standard products for autonomous applications, we're looking at what is driving the development of these. And a lot of it is coming down to safety. So you don't want to see an autonomous vehicle causing any sort of damage, or to itself or to the general public, of course. But also you want to see the end goal for autonomy is that you want reduced costs, you want productivity gains, you want a more efficient workplace or a more efficient traffic system. And those technology drivers that I mentioned lead to things like sustainability. The Department of Energy has estimated that as we move towards more autonomous vehicles and more autonomous technology, we could see like a 90 to 200% decrease in energy consumption, which is great for everybody. So that's the things that are driving us to develop these products so that our end users can benefit from the autonomous applications that they're trying to use.
Yeah, that makes a lot of sense. And, the safety thing, it's obvious with automotive applications, but you talk about industrial IoT, you've got robots and cobots working in and around people. And so safety is a concern there. And obviously heavy equipment applications, those are dangerous areas just by definition.
For sure. And, I should stress more that the safety behind, there's the great commercial aspect of autonomous technology, but the safety aspect of being in a mine, it'd be better to keep the people out of the mine and have the machines do all the work than, to risk someone's safety and health.
That's exactly right. So what are some examples of specific RF applications within these autonomous systems?
Well, I like to think of this automotive applications in a lot of ways. It's like a person. So, the applications are these compute and ADAS modules. Think of those as the brain of the autonomous vehicle. Those are fed by inputs and data from the outside world through cameras, of course. Think of the cameras as being the eyes of the system. So you have to maintain all of these connections between the compute modules, the cameras, the V2X communication systems, GPS, LiDAR, and radar. Those would all be, sensor type applications. That's your sense of touch. So it's very much like, you're putting a living thing into the world. It's an autonomous vehicle, but it really, you want it to be able to react and be, as in the world and reactive to the world as possible. So it's good to think of it as a living thing in that way. So that's why all of these applications are so important.
Yeah, I recently discussed environmental sensing for autonomous driving applications on another tech chat, and the number of cameras that they're using, plus multiple LiDARs, multiple radars in every autonomous vehicle looking forward, it's really astounding. So the RF connector and cable count in an autonomous vehicle is going to be very high.
Absolutely. As an RF company, we do what we can to try to reduce the amount of cabling or to make it a little bit more efficient. And I think we'll see that in a little bit here. Some of the things that we're doing to help that effort to make the vehicle or the application a little bit more efficient.
Oh, excellent. Plus, everything you list here could also be used in those other applications from your previous slide, including AMRs, drones, heavy machinery. They're all going to use these kinds of systems.
Exactly. And that kind of goes along with the cascading effect of the automotive industry feeding and influencing these other markets and these other industries. If you're developing the technology for one application, it can be easily adopted into another, or adopted with some effort. Nothing's easy, but it's good to see that we're able to support so many different applications and markets in so many ways with so few products, really. To go a little bit deeper into some of the connectivity in some of these applications, keeping with the automotive theme, the major, most common product line that you'll see in automotive applications is the FAKRA product line. And these are connectors that there's an industry standard. They are made to be mated securely. They're mated without error because they're color coded, because they have a keyed interface. Everything about the FAKRA product line is, says something about safety and efficiency. And the products themselves allow us to connect from the PCB, the printed circuit board, to anywhere in the vehicle for any type of RF application. So we see on, these connectors are made for Wi-Fi, for infotainment, for the GPS system, for Bluetooth. Like I said, anything that has an antenna at the end of it or that is communicating within the car, these FAKRA connectors will mate, and they're harnessed and designed to be fed through the cars. So the FAKRA product line is such a mature product line and so much of an industry standard that there's a lot of solutions available within it, both in the FAKRA line and then as they are needed to be connected to other types of product interfaces like SMAs or the AMC product line. Depending on the size and shape of the application, there really is a FAKRA solution available.
So Ron, what defines a FAKRA connector? Because usually when I hear of a particular connector name like SMA, that I envision a particular style of connector, that certain number, of pins, but these don't all look the same. So what makes a connector here? Some look like they're round, some are kind of rectangular. What makes them all FAKRA connectors?
So a FAKRA connector is technically, it's an SMB interface that is encased in a housing. And the housing is a standard keyed interface as well, so that you can only mate the A housing jack to an A housing plug, for example. You can't mismate them. And then the industry has also defined colors for certain applications. And I don't know exactly which applications go to which, but for example, let's say FM radio would be a blue connector. So you'd have your big cable harness with all of these connectors on one end. The assembler would be mating them all. They would know the blue one goes to the blue one. The brown one goes to the brown one. So it ensures the efficiency of manufacturing and the safety. Again, you're not going to accidentally mismate a GPS function into infotainment. It allows for the manufacturers to have the peace of mind to provide a product to the consumer that's going to be safe and correct. And so in talking about FAKRA, the next evolution, because everything in the world is getting smaller and more compact, is what's called the Automate Mini-FAKRA. Now, there are two industry standard solutions that are available from Amphenol, and they do work. They are compatible with all other existing solutions. It goes along with that industry standard of manufacturers. But the Mini-FAKRA, it increases the density of connections. So you save 80% of your space using the Mini-FAKRA versus a FAKRA. So one connection of a Mini-FAKRA is actually 4 RF lines being mated rather than just the one. So coming out of that cable, you're going to have one connector with 4 cables coming out of it, which can be routed in any way you need it. But the PCB connection will have that one jack or plug, as it's called on a FAKRA system. It will have that one terminated connector on the PCB. So you're saving, instead of having the 4 connections in a row, you're just having one. And it's also been designed to grow. So right now the frequency limits are lower than what we've designed them for. So as data rates are improved and you need a better, higher speed connection, we've built that in to grow into the connector.
Now, I see in this list of specifications here, one of the things is CPA for connector position assurance and TPA for terminal position assurance. What's the difference between those two?
So the connector position assurance is for the housing latching system. So it's the tolerance that we allow for a good, secure mate between the housings. The terminal position assurance is for the 4 RF lines inside the connector. They mate correctly as the housings are also being mated correctly. Every RF connector has either a jack or a plug or a socket or a pin contact, and those mate without crashing, without deforming, and that's what is assured in using these housings, is that they mate without fail.
Oh, that makes sense. Thank you.
And so I just want to touch on, just very quickly, the camera and smart antenna interconnect systems that are available. We're not a manufacturer of cameras or antennas. There are other Amphenol divisions that do those things that we work with, but we do design some of the interfaces and work with these other divisions to make that technology happen. So we do have a special camera interconnect that we work with. And then we have this HDEFI board-to-board system that works in the antennas. So I want to just mention that we're working the other suppliers of this technology to make sure that they get the technology they need to make their applications work. To move along, we mentioned the evolution of these applications, and now the RF in industrial autonomous applications is starting again. So as we mentioned before, the evolution of these applications has easily moved us into the industrial autonomous space. where really there's an entire we like to call it an industrial ecosystem of applications that exist both in the heavy equipment as well as the industrial warehouse type applications. There really is a lot of overlap. We think of it as one space. So in this space, you have your GPS and real-time location systems, which everyone knows what GPS is, but we also support GNSS, which is a global system. That is made up of many different regionally located GPS systems that allow for global tracking. And of course, we support Wi-Fi cellular, so that has a lot of implications to warehouse and robotics within a warehouse. Bluetooth, the same thing. In order to communicate locally, that's necessary. RFID is what is used for asset tracking. And again, we come back to cameras and vision systems, which are absolutely necessary for autonomous systems. It's one of the biggest safety features of an autonomous system.
And this list of applications, the GPS, the Wi-Fi, Bluetooth cameras, those overlap, as you're kind of noting before, with the autonomous driving, the commercial vehicle kind of stuff. And so you're seeing how those things are just pushing into other environments and probably goes both directions to some extent. And so having common connectors and common cabling and those kind of solutions is probably useful. But I'm guessing for the industrial environments and the heavy equipment, you have a much more robust set of requirements for the environment that they work in.
Yeah, absolutely. And in a few minutes, we will talk about some of the features of some of our products that are more applicable to a industrial or warehouse environment, like ruggedized products, waterproof products, and then even super miniaturized products. We call them ultraminiaturized. And speaking of ultraminiature products, these are products that the PCB connector of these types of products is no larger than 3 millimeters by 3 millimeters on a PCB. So they're really, really tiny. You can pack a lot of them into an application, and those connections are used in wireless modules that they might be something of an aftermarket type application that you can add to an existing application that will make the autonomy that much easier. So inside that wireless module, you would mate your jumper to that tiny PCB connector and route that to a panel with an SMA-based antenna or a TNC-based antenna. And so we have this huge portfolio of connectors that terminate to this microcoax, and these microcoax are less than 2 millimeters in diameter. So they're super tiny, super flexible. You can route them anywhere within the module. It allows PCB designers to not be limited by what connectors need to be on the edge of a board so you can mount it to a panel, that type of thing. So it does allow for a lot of versatility in the design. But like I said, we have these the wireless module side connectors where it's our AMC and AMC4 are the primary ones, but we also do MCX, MMCX, and SMA. We do go as large as RG178 cable. When I say that, it's 1.78 millimeters in diameter. We have this enormous selection that allows for this versatility in design for these applications.
And this slide kind of encapsulates something that you touched on briefly earlier, that everything is getting smaller and frequencies are getting higher. There's the note here about some of these supporting Wi-Fi 6 and 6E, which is up in the 6 gigahertz band, which, there wasn't really anything in the commercial world working at 6 gigahertz a few years ago. So it gets smaller and faster.
Absolutely. I mean, 10 years ago, we had these spec'd at 6 gigahertz thinking that was the highest tech you can get. And then now we see the requirements are now for 7.1 and getting higher. So we have been revalidating all of our products to make sure that they will work to the 7.1 and higher as we're going along. So we're doing our due diligence to make sure we're providing the products that will perform in the applications that they're needed in. Now to talk about some of the more interesting or the robust features of some of our products. The first thing we'll talk about is the IP67 or 68 rated products. We have over 300 different products which are rated to this IP67 sealed specification across 14 different product families. The intent of these is that they can protect the electronics that are inside the box or inside the panel. You can have the peace of mind of developing a product that will work, in a wet environment for some period of time. Again, the versatility we have offered in the number of cable types that are supported, the product interfaces that we have, like I said, 14 different ones, and as well as just the body styles and the PCB mounts and the cable mounts. We do have a lot to offer that will help in most designers' minds. If you're picturing something, we probably have a connector that will work for the application you need.
And what is the difference between IP67 and 68? I don't live in the connector world, and I'm sure a lot of our audience doesn't either. So what's the distinction?
So IP67 is a defined standard where it will withstand harmful dust particles, and this is talking about we'll refer to it as an exposed or unmated interface. So a connector that's exposed to the environment can withstand. The 6 refers to the dust particles. It'll withstand harmful dust for up to 8 hours. And the 7 is referring to the spec of moisture protection. And in this case, it says it will survive for 30 minutes submerged to 1 meter, up to 1 meter for 30 minutes. So you get an idea of how robust or how much that connector can take in the world, how much exposure it can be subjected to live where these applications are occurring. So you got these industrial applications, there's a chance that there's going to be some moisture getting, or some, it might be out in the environment. It might be in the rain for a little while. That's what IP67 is. IP68 it's the same physical dust spec, but the 8 indicates that there's a custom requirement that is above and beyond the 1 meter for 30 minutes. Usually it's a customer defined spec. So for our IP68 products, what those products are most likely they were custom solutions for someone whose application went end of life, and now we're able to offer it as a standard product. So you're going to get a better than IP67 rating for that type of product. And it is different for every customer application.
If I understood correctly, 6 is dust protection, 7 is water to a certain level, and then 8 is also water, but to a custom level, and you kind of need to look at the spec for that particular part to know exactly what it is, but it's better than 7.
Correct.
Oh, good. I passed the test. Now, dust and moisture are just 2 of the problems you experience in these harsh environments. I'm assuming you have some connectors and cables that support some of the other challenges of these harsh and rugged environments.
Yes, we do have a ruggedized line. We call it the ARC line, which is Amphenol Ruggedized Connector. And these are, we like to think that these are, when we picture them, they're ideal for the worksite infrastructure system. So these are going to be IP67, both mated and unmated. They've been engineered to be crush resistant. So, they can be run over by a truck tire, perhaps. Don't quote me on that. I haven't done the research. But the construction themselves, when we say that, it's because, they're machined from one piece of metal, one piece of brass or stainless steel, as opposed to, some commercial construction is made up of 2 pieces pressed together, and that's done for efficiency in manufacturing where you can, you're using common components and you're just changing one piece or another. These are not that. These are, like I said, single piece construction that are intended to be, it's like using a rock. For our cable mount connectors, they include adhesive lined heat shrink tubing that ensures that IP67 waterproof sealing on the back side of the connector. So where the cable meets the connector, where it's terminated, that's another access point for moisture that we're eliminating by including the heat shrink tubing. And again, we try to design to to work with all of the standard or common type of worksite or industrial cabling solutions. And a lot of that includes the Times Microwave LMR type cable.
And I'm guessing that cables and connectors are probably one of those areas that people who are designing systems really want to cut corners to save costs. But any type of failure or downtime in one of these harsh environments not only means that you have to repair it, but it's probably more difficult to repair, more costly. You're probably in a location where you don't have a lot of spares lying around. So it's probably not the best place to actually cut costs in your development.
That's absolutely true. As easy as it is to terminate some of these connectors, it's not as easy to do in the field when you've had an outage, when you're under the gun. So we design them to withstand as much grief as possible.
That makes sense.
All right, and so one other thing that it's relatively new to us right now that we're offering are these different industrial plating options. There's two of them that we're introducing. One being the black zinc cobalt finish, and the other being a tin nickel corrosion resistant plating. So they both have different reasons to be used. The black plating one, we're really envisioning it being something that the military or law enforcement being interested in. It's got a non-reflective finish. It helps you maintain your incognito status when you want to be. But at the same time, it's been tested to be as electrically, to have as good electrical performance as a nickel or other durable plating. The tin nickel plating is the one where we designed it for corrosion resistance for these harsh environments. We've tested it for 720 hours, which, do the math, that's a whole month. So you can, expose these connectors for, a month at sea if you want, and they'll perform and they'll maintain their performance that whole time. So it's something we're very kind of excited about and want to make sure everyone knows about.
Yeah, those are exciting and more unusual applications. From the products you've covered today and the long list of connectors and cable options that you've described, I'm thinking Amphenol RF probably has an off-the-shelf solution that will meet most people's needs. But for those special requirements, what services do you provide for custom cabling and connectors?
Well, you are right that we, when we introduce something, we do try to introduce every variation of it so that it's easy for customers to find in distribution. I believe Mauser has many of these products stocked regularly. But, there is always going to be a need for custom solutions, and we're very proud of the engineering team that we have. It is truly a worldwide engineering team because we do design work all around the globe. We have manufacturing expertise and manufacturing capabilities of all types, again, all around the globe. So we're not limited by the design based on what we're able to do because we can really do just about everything. I'm remiss to think of something, someone will call me on something that we can't do, but there's always an Amphenol sister division for that. But when it comes to RF connectors, we really do have our act together. Our engineering team is able to take a customer requirement, fit it into the package size they need using either standard connectors or a custom interface if necessary, design the PCB launch so that performance from the connector onto the PCB is maintained and meets the requirement. And then we also can work with other non-RF interfaces, either with the help of other divisions or just from the general know-how of how electronics work. We have that capability. And again, with the engineering team, they have all the tools to get this done, all your network analyzers and engineering drafting software. And I mentioned, the global manufacturing. We do have high-speed machining, we do stamping and forming, and the prototyping in our model shops. Agile is the best word to describe them. And then just to top that all off, our quality team is always there to make sure that every interface spec is met, every environmental requirement that the customer has is met. So it is a great technical team that we have to do these types of things.
And I would assume that technical team is there to help customers even find the right off-the-shelf cables and connectors to meet the requirements if they need that help.
That's true. And chances are you'll have a 33% chance of getting me on the phone if you call the tech support line, and I'll be able to help you.
Sounds good. We've covered a lot of ground today, so why don't you connect everything together for us?
Well, talking about autonomous applications and what's needed for them, we have an enormous line of RF connector interfaces, adapters for them, cable assemblies, and I mentioned the custom products. These are all of our core competencies and our expertise that we have to really support the growth of these autonomous applications for the markets that we talked about, as well as all of the markets that we haven't talked about, that we haven't even thought about yet. Every idea starts somewhere, and we're the technology these days, things are happening that we never thought would have happened. We never thought that entrepreneurs would be using FAKRA connectors in their own little labs. We thought that was always going to be a super high efficiency, mass produced connector only used in the automotive industry. So we're seeing people using connectors everywhere. We're happy that we have this huge line of products that can be used by designers, big and small, to get their applications off the ground.
Yeah. And speaking of that huge line of products, I love here how you have this really long list of connector interfaces and you still have to say more.
Yeah, there are a few that aren't on there that, that's kind of funny.
Well, thank you, Ron, for that overview of RF interconnect selections for autonomous technology. It was great having you join us on Tech Chat today.
Thanks. It was good to be here, and I look forward to doing this again.
Yeah, I'd be glad to have you back. And as we reach the end of our discussion, we definitely want to thank our sponsor, Mouser Electronics. So if you're looking to purchase any of these Amphenol RF products, head on over to Mouser.com to thank them for supporting educational presentations like this. And join us again next time on Tech Chat, where we chat with the leading technical experts like Ron Orban from the world-leading innovative companies like Amphenol RF, who are changing our world every day.